All right, guys, let's get going on some radical equations here. The good news is just like absolute value equations, you want to isolate, just like you isolated the bars for those, you want to isolate the radical for these. So if we took a look at number 1, my goal is to isolate this radical. So if anyone's thinking, hey, Ms. Logus, you should probably add that 3, I agree with you completely. In fact, if I had the square root of 5 minus x, that would then equal 3. And then because a lot of you are so experienced with this, if you're thinking, how do I get rid of a square root? If anybody is thinking square both sides, I agree with you. The square and the square root are inverses, so they would cross out, and you'd just be left with 5 minus x equals 3 squared, or 9. So now that this is a linear equation, if I quickly subtract 5, get negative x equals 4, so that means that x equals negative 4. Awesome, we have a singular answer. Bad news is just like the other videos before this, we need to check for extraneous solutions. So if I take the negative 4 and plug it back into the original equation for x, we'd have the square root of 5 minus negative 4 minus 3. Does that indeed equal 0? Well, 5 minus negative 4 is 9. The square root of 9 is 3. 3 minus 3 does check out to be 0. So this is for sure an answer to number 1. Number 2, the reason I chose this one to be in the video is because instead of a square root, we're dealing with a cube root. Now, something that will help you in just a minute solving these, remember that something to the cube root, so if I have the cube root of x, that is actually the same thing as x to the 1/3. And actually, in the problem number 1, the square root of something, the square root of x, is the same as x to the 1/2, which is why when you square both sides of the equation, it ends up canceling out because 2 times 1/2 is 1. And in this case, if I wanted to square cube both sides, the 1/3 times the 3 ends up becoming an exponent of 1 as well. That will also help you in a later video. So anyway, back to isolating. If you already got ahead of me and we have the cube root of x minus 3, we subtract the 7, we would get negative 5. Now, like I was saying up here, if you want to get rid of a cube root or to the 1/3 power, you would cube both sides of the equation. Then the cube and the cube root are inverses. So just like last time, we're left with x minus 3 equals negative 5 cubed. Now, negative times negative times negative is a negative. 5 times 5 times 5 is 125. So if I solve the equation, I would get a very large answer, or I guess really small if it's very negative, of a negative 122. Now, just to make sure, I want to check this again. So if I take my negative 122, plug it back into the original, is the cube root of negative 122 minus 3 plus 7, does that equal 2? Well, this ends up becoming the cube root of negative 125. The cube root of negative 125, or what number times itself 3 times, gives you negative 125, is negative 5. And is negative 5 plus 7 equal to 2? It indeed is. So this answer, again, did check out. Now for the real fun. Just like the previous 2 examples, we need to isolate the radical. So your first move would be to subtract x. Fine and dandy. However, when you have the square root of 31 minus 9x equal to 5 minus x, you all know that you can't combine these because they're unlike terms. So what do? Well, just like the last examples, if I want to get rid of that square root, we need to square both sides. Now, the problem with that is on this side, you end up getting a binomial squared, which if you wrote it the right way, ends up being FOIL. So this side ends up being 5 minus x times 5 minus x. This side, inverses, 31 minus 9x is left over. So if I go through this algebraic fun, I would get 25 minus 5x minus 5x plus x squared. 31 minus 9x equals 25 minus 10x plus x squared. Looks like going to be a factoring problem. We would end up with x squared on this side, add 9x and get minus 1x, subtract 31 and get minus 6. Two numbers that multiply to be negative 6 and combine to be negative 1 are negative 3 and positive 2. So my two possible answers are 3 and negative 2. So let's take the time to check both, because it is, as I'm sure you've noticed, very important to always check your work, calculator or in your head, or by writing it down. So if this is my original equation, let's first check 3. So every time I see an x, I'm going to plug in 3. 31 minus 9 times 3, does that question mark equal 5? Well, we'd have 3 plus the square root of 31 minus 27, which is 3 plus the square root of 4, which is 3 plus 2, which does equal 5. Check. 3 works. If I'd like to check the second one into the original, and every time I see an x, I'm going to plug in negative 2. Let me change colors here. So I'd have negative 2 plus the square root of 31 minus 9 times negative 2. Does that also equal 5? Question mark. So negative 2 plus 31 plus 18. Does that equal 5? Negative 2 plus, that would be 49. The square root of 49 is 7. Does negative 2 plus 7 equal 5? Yes, it does. So negative 2 also works as a solution. Awesome. This last example can be quite a doozy, and you will see why. But kind of stick with me on this. It ends up being a little bit of an algebraic, some might say nightmare, some people like me might say absolute delight, but it kind of depends on you. So let's go through this example together. All right, you notice that there's two radicals. Just like the last three examples, let's try to isolate one of the radicals. And I don't know about you, but because this radical is positive and this one's negative, I'm thinking about adding this to the other side. So let's change this to the radical 2x plus 5 equaling 1 plus 2 root 2x. So if I want to get rid of this radical, just like the last couple, let's square both sides. So over here, inverses, we'd have 2x plus 5 left over. Here, just like the last problem, ends up being FOIL because you're doing a binomial times itself. So I'm going to write it out because you are much more likely to get it right if you show your work. Trust me on that. So if I FOIL this side, I would get 1 plus 2 root 2x plus another 2 root 2x. Now this is the tricky part. This is where you need to take your time. When you multiply these two things together, you're multiplying 2 times 2, so you're getting 4 root 2x times root 2x. Now just like root 3 times root 3 ends up being just 3, root 2x times root 2x ends up just being 2x. So this becomes 4 times 2x here. And that's still equal to 2x plus 5. Now, if I keep simplifying, I end up seeing a little bit of a problem. 2x plus 5 equals, if I combine like terms, 1 plus 2 root 2x plus another 2 root 2x is 4 2x's plus 8x. Now here's why this one is such a pain. We have another radical, and the goal of all these problems is to isolate the radical so that we can get a final answer. So what we're going to have to do is move the 1 and the 8x over and square both sides again. So if I do that and I move the 1 over, I'm going to get a 4, and if I subtract the 8 over, I'm going to get a negative 6x. So I have negative 6x plus 4 equals 4 root 2x. Now something I notice before I square both sides so that my numbers are easier, I noticed that the 4, 4, and 6, you can take out a 2 out of all of them. So let's divide everything by 2 because it's an equation. No, I cannot divide the radical by 2 because this is an unlike term. So this becomes negative 3x plus 2 equals 2 root 2x. And all of that's under the radical. Now, we need to get this, we need to get rid of that radical. So what we have to do is, again, I would just square both sides as you see them. So this becomes FOIL again. Negative 3x plus 2, negative 3x plus 2 equals, and I'm going to write this out as well, just so you can see my work, 2 root 2x times another 2 root 2x. Here, if I FOIL both sides, I'd end up with 9x squared minus 6x plus 4. And on this side, 2 times 2 gets me 4. Root 2x times root 2x ends up just being 2x. So, man, this problem is quite a doozy, as I said. You get 9x squared minus 12x plus 4 equals 8x. Thank goodness these pages can scroll down forever, because I am definitely using my room today. All right, let's keep going. So if I get everything equal to 0, we'd have 9x squared minus 20x plus 4 equals 0. Okay, now I need to factor 9x squared minus 20x plus 4. I notice these are perfect squares, but just to make sure I get it right, I'm going to have to split the middle. Now, you're probably wondering, wait a minute, Mrs. Logus, not only did you give us a problem that you have to FOIL multiple times and square both sides multiple times, now it's not even easy to factor. Now I need to still split the middle. Why indeed I did, guys, and I think it's better in the video to see something like this so you expect it or have an idea what to do when you see it in class. So anywho, if I do a times c, I would get 36, and the two numbers that multiply to be 36 and combine to be negative 20 are going to be 2 and 18, both negative. So if I split the middle term, we'd have 9x squared minus 2x minus 18x plus 4. Now you could have switched these two if you'd like. If I think GCF, we would have x, 9x minus 2, and take out a 2, negative 2, get 9x minus 2 again. So this would factor to be x minus 2. 9x minus 2 equals 0. So my two possible answers are positive 2 and positive 2/9. Now, we are still not done with the problem because we still need to check. So what I'd like you to do is, for the first time this whole video, I want you to pause, check both, and see which one works. I will come back with my work. All right, so to check back in with you guys, when I checked both answers, I actually ended up getting x equals 2 did not work. When I plugged 2 back in for x, I ended up getting that negative 1 equals 1, which is not true. However, I had used my calculator for this one just to make sure. When I plugged 2/9 every time I saw an x, I ended up getting the square root of 5.4 repeating, which is 2.3, minus 2 times 0.6, so I ended up getting 2.3 minus 1.3, so I ended up getting that 1 equaled 1. So funny enough, 2/9 did work in this case, and the other answer of 2 did not. So the answer is just 2/9. All right, guys, thanks for sticking with me. We're definitely going to be practicing this tomorrow in class, especially one like number 4. Have a good evening or whenever you're watching this, and I will see you next time.